Dear friends, now let us discuss one very important result, that is Gauss divergence theorem. So now let us understand the statement of Gauss divergence theorem at the very first time. So now what is that? Let V be the, understand this, let V be the volume. So look at me, V be the volume bounded by the surface S, bounded by the surface S, and let and if F vector, as you know, that be a continuously differentiable vector function, be a continuously differentiable vector function, then it's a very simple definition. Then what's the Gauss divergence theorem says that a double integral over S f dot dv sorry, that f dot n cap ds is equal to triple integral over volume V. Nothing but this also, this is surface integral and it is a volume integral. When it is a line integral, you have only one time integration. When it is a surface integral, two times of integration. When you have the volume integral, three times of integration. So surface integral f dot n cap into ds is equal to volume integral. That means a triple integral over volume V, that is equal to divergent f dot dv. That's it. Divergent f into dv. Or this can be simply taken as a surface integral as f dot n cap ds, that is equal to, this can also be taken as triple integral over volume V. This is divergent f is nothing but del dot f into dv. This is a statement of the Gauss divergence theorem. Let us once again understand. Let V be the volume bounded by the surface S, and f be a continuously differentiable vector function. Then double integral over S f dot n cap ds is equal to triple integral over volume divergent f into dv. Or this can also be taken as, instead of divergent f, that can be taken as delta dot f. Here there is very important word is flux. The flux is always given by a double integral over surface f dot n cap into ds. This is very important result, very important result. Now let us find out some basic problems related with this Gauss divergence theorem. Understand this? Okay, now have a look on this. Okay, now let us take one more problem. If f vector is equal to, very important result. If f vector is nothing but a continuously differentiable vector function. That's it. Okay, very simple problem. If f vector is equal to 2xyi, if f vector is equal to 2xyi, I is nothing but I cap plus yz square j plus xzk, and S is the rectangular parallelepiped. Understand this? And S be the rectangular parallelepiped. Rectangular parallelepiped bounded by very easy thing. Boundary condition they are given. Bounded by x is equal to 0, y is equal to 0, z is equal to 0. These are the lower boundaries, and and x is equal to 2. Have a look on this upper boundaries. X is equal to 2, y is equal to 1 and z is equal to 3. And z is equal to 3. Find the flux across S. Find the flux. Find the flux across S. Have a look on this. So here the very important thing is we have to find out the flux here. We know that flux is equal to a double integral over S f dot n cap into ds. This is a formula to calculate the flux. But by using when they are using the word flux across surface area, yes, we have to use the Gauss divergence theorem. By using divergence theorem, simply I have written divergence theorem. So have a look on this. By using divergence theorem, what is the formula here? So double integral over S f dot n cap into ds is equal to a triple integral over volume. So del dot f into dv. This is the formula. Okay, now have a look on this. This portion, double integral over S f dot n cap into ds, nothing but flux. Therefore, flux is given by the formula a triple integral over volume del dot f into dv. So now this is equation number 1. So now let us first find out del dot f into dv. So now for that, what is f here? Now f is a function here, vector function. What is f here? So f is equal to, what is f is equal to 2xyi plus yz square j plus xz into k. So now let us find out del dot f. What is that in del dot f? I have to consider here del dot f. How you will get del dot f? So del dot f is equal to dou f1, that is the first function, divided by dou x plus dou f2 divided by dou y plus dou f3 divided by dou z. So here f1, f2, f3 are the, f1 is the first function, this is f1, this is the second function f2, this is the third function f3. Now let us differentiate here. Dou f1 by dou x, nothing but I can write here simply. So dou by dou x of f1 is nothing but the first function, that is 2xy plus dou by dou y of second function f2, what is that? yz square plus dou by dou z of f3. f3 is nothing but third function across k, xz. So now differentiate with respect to x, y remains constant, derivative of x is 1, remaining is 2y, plus here with respect to y, so derivative of y with respect to y, that is 1, remaining is z square, plus derivative of derivative of z is 1, remaining is this. This is what the formula for del cross f. Now we have to find out triple integral over volume del dot f into dv, that we have to find out. What is dv? Is nothing but dz into dy into dx. That's what. Okay, now let us find out that. Okay, now I hope this thing is over. So now we have to consider which part. So RHS part. What is RHS part here? Have a look on this. So this is a triple integral over volume. So del dot f into dv can be taken a triple integral. So the first integral, x is equal to 0 to 2, right? 0 to 2, and y is equal to some 0 to 1, and z is equal to some 0 to 3. So you have to write the del dot f. What is del dot f? So that is 2y plus z square plus x into dv. dv is nothing but dx into dy into dz. Nothing but here first we have to integrate with respect to z. I can write dz dy into dx. Okay, this is what the formula. Now integrate 1 by 1. X is equal to 0 to 2. So y is equal to 0 to 1. Okay. Now integrate of 2y is 2yz plus z square is z cube by 3 plus x is xz. So from where to where? From 0 to 3. Remaining is what? Dy into dx. So now x is equal to 0 to 2, y is equal to 0 to 1. So apply the upper limit and lower limit. No need of applying the lower limit here. Here these values are z values. Okay. So y is z is 3 here. 2 3 is a 6y plus 3 square is 9. Sorry, 3 cube is 27. 27 by 3 is 9 plus x z is 3x into dy into dx. Now you have to integrate with respect to y now. So this is become x is equal to 0 to 2. So integrate this 6 into y integral is y square by 2 plus 9 is 9y plus 3x is 3x into y. Am I right? So from where to where? 0 to 1. Remaining is dx. Now substitute the values here. I can write this one. Okay, now what happens here? So that is equal to x is equal to 0 to what? That 2. 6y square 2 3s are, it goes up 3 square. 3 into y value is what? 1. Here lower limit no need. That becomes what? 3 plus 9 plus y value is 1. So 3x into dx. So now remaining thing is x is equal to 0 to 2. 9 plus 3 is 12 plus 3x into dx. Now you need to integrate that. That is equal to 12x plus 3x square by 2. From where to where? 0 to 2. Now just apply the upper limit. No need of lower limit here. So that becomes 24 plus 2 square is 4. 4 3 is 12. 12 by 2 is 6. That is equal to 30. So I think that is equal to 30. That's fine. So this is nothing but volume integral V. So what is that? Del dot F into dV. This is nothing but flux. Therefore flux is equal to 30 units. That's what. Okay, let us consider one more very important problem related to this only. Okay, what is that, sir? So the second problem. What is the second problem here? Evaluate. This is very simple. Very simple. Evaluate. Look at the second question. Evaluate. So double integral over s axi plus byj plus czk int dot n cap ds. So this is in the form of f dot n cap into ds, right? So where s is the surface of the sphere, and you know that what is the sphere equation? That is x square plus y square plus z square is equal to 1. We have to just evaluate that. Okay. Now let us consider this is in the form of double integral over s f dot n cap into ds, right? So now using divergence theorem, I can write dt. Dt is nothing but divergence theorem. Don't write dt. I simply for the space purpose have written like that. So that is given by a double integral over s f dot n cap into ds is given by triple integral over volume. What is the formula here? Del dot f into dv. Okay, now here this is let it be as equation number 1. Now we have to find out del dot f. So del dot f is given by, this is as you know that dou by dou x of f1, that is the first function across I. So dou by dou y of f2, that is across j. So dou by dou z of f3. Now just f1, what is f1 here? Ax, we can write. So dou by dou x of f1 is ax plus dou by dou y of f2. What is f2? Second function. What is that? by plus dou by dou z of f3. That is a third function. What is that? cz. So now if you differentiate with respect to x, ax is a, by is b plus cz is c. This is what del dot f. So this is what a plus b plus c. Therefore equation 1 becomes, what happens to equation 1? So equation 1 becomes, so that is a double integral over surface del dot f, sorry, what is that? F dot n cap into ds is equal to volume integral, that is nothing but triple integral over volume. Del dot f is nothing but what? A plus b plus c into dv. dv is nothing but, I can write dz into dy into dx. This is what. So or simply you can take this one, yes, this one. You can take, this is nothing but, or simply you can take this one, okay. This is dv itself. Later we can write something. Here you can take a plus b plus c is a constant thing, we can take. So that is equal to a double integral over s f dot n cap into ds. A plus b plus c is outside, since it is constant, remaining thing is a volume integral over 1 into dv. Nothing but dv. This is nothing but volume of the sphere. So this is nothing but a plus b plus c into this entire thing is nothing but volume of sphere. Volume of sphere. So that I can write a plus b plus c into volume of the sphere is 4 by 3 pi r cube, right? Am I right? So 4 by 3 pi r cube. 4 by 3 pi r cube. But r is equal to 1 according to the equation x square plus y square plus z square is equal to 1 represents the equation of a sphere with radius is 1. Okay. Then it become what? A plus b plus c into 4 by 3 pi only. So this is the double integral over s f dot n cap into ds. This is the evaluation of the given problem using Gauss divergence theorem. I hope you all understand well about this, right? Thank you.